Grounding is important for home computers for several reasons. Firstly, electrostatic discharge, or ESD protection. Hard drives, cooling fans, and other components can generate electrostatic charges due to friction. If these charges build up, they can damage sensitive electronic components. A ground provides a path for these charges to be dissipated safely. Secondly, surge suppression. Grounding helps to protect computers from surges and power line disturbances. When a surge occurs, the electrical current can be diverted to ground, preventing damage to the computer. Thirdly, safety for the user. Grounding reduces the risk of electric shock to users by providing a low impedance path for electrical faults. If a ground fault occurs, the current will flow through the ground wire rather than through the user. Regarding the adequacy of GFCI receptacles for computers, GFCI receptacles are designed to protect against ground faults. While they can provide some level of protection for computers, they are not a substitute for a dedicated grounding wire. GFCIs do not provide surge suppression. Surges can still damage computers even if they are protected by a GFCI. Furthermore, GFCIs do not provide a path for dissipating electrostatic charges. Therefore, computers connected to GFCI outlets with no ground wire may still be susceptible to ESD damage. The recommendation for clients is to always use a computer with a proper ground connection. If a ground wire is not available, consider using a surge protector with a grounding terminal. Avoid connecting sensitive electronic equipment to GFCI outlets without a ground wire. Some computer manufacturers may allow for the use of GFCI outlets without a ground wire, but this is not recommended. The National Electrical Code, or NEC, only allows GFCI outlets without a ground wire for specific applications such as knob and tube wiring. For refrigerators and freezers, a ground wire is essential for both safety and proper operation. Grounding is a critical safety measure in electrical systems, providing a path for fault current to return to the source, thereby tripping a circuit breaker or fuse and energizing the circuit. This prevents electrical shock hazards and minimizes the risk of fire. A properly grounded system ensures that metal enclosures of electrical equipment are at or near ground potential, reducing the likelihood of voltage differences that could cause a shock. In addition to safety, grounding also plays a vital role in the proper functioning of electronic devices. Sensitive electronic components can be damaged by voltage surges and electrostatic discharge. A well-designed grounding system provides a low impedance path for these disturbances to dissipate harmlessly, protecting the equipment from damage. The NEC outlines specific requirements for grounding electrical systems, including the size and type of grounding conductors, the methods of connecting to ground, and the bonding of metal enclosures. These requirements are intended to ensure that the grounding system is effective in providing both safety and equipment protection. Grounding electrodes, such as ground rods, ground plates, or metal water pipes, are used to connect the grounding system to the earth. The NEC specifies the minimum size and depth of these electrodes, as well as the requirements for their installation. Bonding is the process of connecting metal enclosures and other non-current carrying metal parts to the grounding system. This ensures that all metal parts are at the same potential, preventing voltage differences that could cause a shock. The NEC requires that all metal enclosures be bonded to the grounding system, including electrical boxes, conduit, and equipment frames. Ground fault circuit interrupters, or GFCIs, are devices that detect ground faults and quickly de-energize the circuit. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electric shock. While GFCIs provide excellent protection against ground faults, they do not provide protection against voltage surges or electrostatic discharge. Surge protectors are devices that protect electronic equipment from voltage surges. Surge protectors work by diverting excess voltage to ground, preventing it from reaching the equipment. Surge protectors are available in a variety of types, including whole-house surge protectors that protect all of the electrical equipment in a home and point-of-use surge protectors that protect individual devices. Electrostatic discharge, or ES, is the sudden flow of electricity between two objects with different electrical potentials. ESD can damage sensitive electronic components, even if the discharge is not noticeable. ESD can be prevented by taking precautions such as wearing anti-static clothing, using anti-static mats, and grounding electronic equipment. The NEC provides specific requirements for grounding computer systems and other sensitive electronic equipment. These requirements are intended to ensure that the equipment is protected from voltage surges, electrostatic discharge, and other electrical disturbances. The NEC also requires that computer systems be isolated from other electrical equipment to prevent ground loops. A ground loop occurs when there are multiple paths to ground, which can cause unwanted current flow and interference. Proper grounding is essential for the safety and proper functioning of electrical systems and electronic equipment. By following the requirements of the NEC and taking appropriate precautions, it is possible to minimize the risk of electric shock, fire, and equipment damage. Always consult with a qualified electrician to ensure that your electrical system is properly grounded. It is important to understand the difference between grounding and bonding. Grounding is the connection of an electrical system to the earth, while bonding is the connection of metal parts to create a low impedance path for fault current. Both grounding and bonding are essential for electrical safety. The grounding electrode conductor, or GEC, is the conductor that connects the grounding system to the grounding electrode. The GEC must be sized according to the requirements of the NEC. The equipment grounding conductor, or EC, is the conductor that connects the metal enclosures of electrical equipment to the grounding system. The EGC must also be sized according to the requirements of the NEC. It's crucial to remember that simply having a 3-prong outlet does not guarantee that the outlet is properly grounded. In older homes, it's common to find 3-prong outlets that are not connected to a grounding wire. In these cases, a ground fault will not trip the circuit breaker, and there is a risk of electric shock. If you are unsure whether your outlets are properly grounded, you should consult with a qualified electrician. They can test the outlets and determine if they are properly grounded. If they are not, they can install a grounding wire or recommend other solutions. One common solution for ungrounded outlets is to install a GFCI outlet. GFCI outlets provide protection against ground faults, even if there is no grounding wire. However, GFCI outlets do not provide protection against voltage surges or electrostatic discharge. For sensitive electronic equipment like computers, it is always best to have a properly grounded outlet. If this is not possible, you should use a surge protector with a grounding terminal. A surge protector with a grounding terminal will provide protection against voltage surges and electrostatic discharge. When working with electrical systems, it is important to follow all safety precautions. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electrical systems, you should consult with a qualified electrician. Grounding is a complex topic, and it is important to have a thorough understanding of the NEC requirements. A qualified electrician can help you ensure that your electrical system is properly grounded and safe. Remember that electrical codes and regulations can vary depending on the location. It is important to check with your local authorities to ensure that you are following the correct codes and regulations. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or other professional before making any changes to your electrical system. Understanding the importance of grounding and taking the necessary precautions can help to ensure the safety and proper functioning of your electrical systems and electronic equipment. Grounding systems should be regularly inspected and tested to ensure that they are functioning properly. This is especially important in older homes and buildings where the grounding system may have deteriorated over time. If you notice any signs of problems with your grounding system, such as flickering lights or electrical shocks, you should consult with a qualified electrician immediately. Proper grounding is an investment in safety and equipment protection. By taking the time to understand the importance of grounding and following the necessary precautions, you can help to ensure that your electrical systems are safe and reliable. This knowledge also empowers you to better advise clients on the importance of proper grounding for their home computers and other electronic equipment, ensuring the safety and the longevity of their devices. Remember to consider the specific needs and circumstances of each client when providing advice. Factors such as the age of the home, the type of wiring, and the sensitivity of the electronic equipment should all be taken into account. By providing informed and personalized advice, you can help your clients make the best decisions for their safety and their equipment. Furthermore, staying up to date on the latest electrical codes and regulations is crucial for providing accurate and reliable advice. The NEC is updated every 3 years, and it is important to be aware of any changes that may affect grounding requirements. Participating in continuing education courses and workshops can help you stay informed and maintain your expertise in the field of electrical safety. Ultimately, promoting electrical safety through education and awareness is a vital responsibility. By sharing your knowledge and expertise with others, you can help to prevent accidents and ensure the well-being of your community. Grounding is a fundamental aspect of electrical safety, and a thorough understanding of its principles and practices is essential for anyone working with the electrical systems. Therefore, consider the following points. First, ground provides a low impedance path for fault current to return to the source, tripping a circuit breaker or fuse and energizing the circuit. Second, grounding protects against electrical shock hazards by ensuring that metal enclosures are at or near ground potential. Third, grounding helps to protect sensitive electronic equipment from voltage surges and electrostatic discharge. Fourth, the NEC outlines specific requirements for grounding electrical systems. Fifth, grounding electrodes such as ground rods, ground plates, or metal water pipes are used to connect the grounding system to the earth. Sixth, bonding is the process of connecting metal enclosures and other non-current carrying metal parts to the grounding system. Seventh, GFCI receptacles provide protection against ground faults but do not provide surge suppression or ESD protection. Eighth, surge protectors protect electronic equipment from voltage surges. Ninth, ESD is the sudden flow of electricity between two objects with different electrical potentials and can damage sensitive electronic components. 10th, computer systems should be isolated from other electrical equipment to prevent ground loops. By understanding these key points, you can better appreciate the importance of grounding and its role in electrical safety.